In this example, we are given that the figure shows LC circuit with initial charge on capacitor 200 microcoulomb. If at t equal to 0 the switch is closed, we are going to find the first instant when energy stored in the inductor becomes 1/3 that of capacitor. Now in this situation, we are given that energy stored in inductor is 1/3 of the energy stored in capacitor. And we know that always energy stored in inductor plus energy stored in capacitor will be equal to the initial energy of the circuit, which is here Q square by 2C. Because initially as there was no current and only electrostatic energy was there in capacitor, we can use this relation. If we substitute UL as 1 by 3 of UC plus UC is equals to Q square by 2C. And we can write energy stored in capacitor at any instant is Q square by 2C, where Q is the instantaneous charge on the plates of capacitor. Because when the switch is closed, it will start discharging, as we have studied in concept of LC oscillations, that as charge decreases, the value of current increases. So if we substitute the value of energy in capacitor here, it will be 1 by 3 of Q square by 2C is equals to Q square by 2C. And here you can see this will be 4 by 3 because it is 1 by 3 plus 1. So in this situation, this 2C gets cancelled out and we'll get the value of charge on capacitor is equals to root 3 by 2 times the initial charge on capacitor. And here we can write for LC oscillations, we can write the charge of capacitor as a function of time can be given as Q cos of omega t. Here I am using cos omega t because at t equals to 0 the charge is maximum. That means it is starting from its extreme position. So its initial phase can be taken as pi by 2. And omega we know well that it is given as 1 by root of LC. Now in this situation we need to find the time, the first instant when the charge in capacitor becomes root 3 by 2 times the total charge. If we substitute it here, you can see we are getting 3 by 2 times Q is equals to Q cos of 1 by root LC into T. So in this situation you can see this Q gets cancelled out and we are getting T by root LC is equals to cos theta is root 3 by 2 when theta is pi by 6. So T by root LC will be pi by 6. This implies the time when it will happen is pi by 6 times root LC. If we substitute the values here, you can see we are getting pi by 6 times root of inductance. We are given with 0.2 into 10 to power minus 3 and capacitance is 2 into 10 to power minus 6. On simplifying the result, we are getting here it is pi by 6 multiplied by 2 into 10 to power minus 5, which is 10.5 microsecond. That will be the answer to this problem.